we look around us, we can see that we are surrounded by many different surfaces: walls, tables, the working top in our kitchen, the floor. But surfaces as we know them today are going to suffer an unprecedented revolution. Today's surfaces can become smart surfaces, thanks to the research that is being carried out in the field of nanotechnology. So the materials that surround us will have properties that would have been unthinkable until now. At the Institute of Nanoscience of Aragon, they are working to make these types of advances in materials a reality. More specifically, their research is focused on producing coatings with special properties, such as fire or water repellency, bacteria elimination capacity, or anti-static capacity. To do this, the team, led by Silvia Erosta, PhD, uses the electrospinning technique.
Parte de nuestro trabajo de investigación consiste en el agregado de nanomateriales a matrices poliméricas. De esa manera se obtiene un material, un producto con propiedades muy superiores a las del polímero de partida.
Coatings with special properties can be obtained depending on the nanoparticles added, such as, for instance, anti-static surfaces that conduct electricity, so they prevent the production of sparks and therefore accidents and harm caused by electricity. Bactericide surfaces able to eliminate bacteria.
Otra de las propiedades que estamos investigando serían las propiedades conductoras en polímeros como el policarbonato, donde utilizamos nanohilos de plata para hacer pasar la electricidad de un lado al otro y conferirle a nuestro recubrimiento propiedades antiestáticas.
Even fireproof surfaces to prevent the propagation of fire. Their application potential is huge, from the protection and safety industry to the construction industry. One of the research lines that have shown significant advances is that of providing the surfaces with hydrophobicity, or the ability to repel water. The ambitious objective will entail creating surfaces that are able to clean themselves.
Además, si formamos estos materiales en forma de nanohilos mediante el electrohilado, podemos lograr recubrimiento de superficies con propiedades hidrófobas, es decir, que repelan el agua. O incluso podrían llegar a dársele propiedades organofóbicas, es decir, que repelan la grasa y compuestos orgánicos en general.
Hydrophobicity can be obtained by reproducing a natural property known as lotus effect. Nature has endowed certain plants with the ability to repel water, to prevent damage caused by prolonged exposure on their leaves, and to protect them from dirt. This characteristic can be seen very clearly on lotus flower leaves, hence its name. Water repellency of a material, like other singular properties, is based on the nanostructure of its surface. At the Institute of Nanoscience of Aragon, they're working to achieve the most adequate coating for each specific application, depending on the final properties of the material and the substratum they have to be applied to.
El punto clave en el recubrimiento de superficies es lograr una buena adhesión entre el soporte y el cubrimiento. Para lograrlo se puede recurrir a estrategias muy complicadas como funcionalizar químicamente el sustrato y el polímero. También hay estrategias mucho más simples como es el calentamiento del sustrato una vez que ya tiene el cubrimiento depositado para lograr una adhesión.
One of the applications with the greatest future potential consists in creating coatings with anti-corrosion properties. These polymeric coatings are not only able to isolate and protect from corrosion, but they may also be self-repairing in the case of a crack on their surface, just by applying heat to it. They are produced with materials that have what is known as shape memory, and their main beneficiaries will be the aeronautical and automobile industries. The possibilities offered to us by research performed in nanotechnology are extremely varied, and this is going to account for an essential basic change in materials as we know them today.